Hello, everyone, and welcome back to the 2018 Hack Summit. We're privileged to be here with Jack O'Halloran, who is the co-founder and CEO of the SKALE protocol and SKALE Labs. And Jack's going to be educating us today on the future of smart contracts and scalability on the blockchain. Jack, it's such a pleasure to have you here, Jack. Appreciate your time today.
Hey, thanks for having me. Pleasure to be here.
Great. So you had a presentation you want to give us. You want to go ahead and open up that slide deck and kind of walk us through your vision?
Yeah. 1 second. All right, Ed, are you seeing my screen?
Yep, looks great. Go ahead.
Okay, excellent. So first off, hey, really happy to be here today. Before I start, I have to apologize. So many of you probably saw our CTO, Stan Kladko, was signed up to present on the deep technical nuances of binary asynchronous consensus, which is a really interesting, heady topic. Stan, unfortunately, got really sick with the flu, so I'm taking over and stepping in and playing pinch hitter. So was able to put together a presentation based off a lot of my knowledge and our perspective here at SKALE Labs. We thankfully have the opportunity to talk to developers all over the world building in decentralized systems and entrepreneurs starting projects around decentralization and blockchains and smart contracts. So what I'm going to do today is share some of my learnings that I've seen from both the business, entrepreneur, and developer perspective that I think will give a unique angle to those of you thinking of working in the space, getting into the space, and as others, entrepreneurs, joining startups, joining projects. Hopefully this will give you a unique perspective based off what I'm seeing. And we will, I also understand we've got a somewhat spread technical acumen and also spread understanding and experience within decentralization and blockchain technology. So I'm going to start more high level just to make sure I'm speaking to everyone, and we'll progressively get deeper as we go. So, and hey, before we get started too, just want to say what an awesome event. I've got the organizations up here that we're all supporting by being here. And Ed and the Hack Summit team, great job. Really appreciate what you guys are doing, and I'm glad to play my role. And all of you here, thank you for being a part of this too. So, okay, without further ado, let's get started. So I'm going to be talking about smart contracts. I get excited about smart contracts. I think this is going to be the piece that takes us into the next era of computing. Before we can talk about where we're going, though, I think it makes a ton of sense to talk about where we are now, because without this frame, you always find yourself in these conversations and you don't go anywhere. So would love to address that. Then I want to talk about incentives and smart contracts. So this is all about incentives. It's the secret sauce of the new internet and this new movement and this new era of computing are incentives. And they're enabled by things such as smart contracts and blockchains, et cetera. So we'll get into that. Then I want to talk about some of the challenges facing progress, and then get into scaling solutions, as that's one big piece here. One challenge is scaling. And at SKALE Labs, that's where we're focused on, as creating a deep, fully decentralized, permissionless, peer-to-peer platform that enables decentralized applications to scale smart contracts to unlimited potential based off the amount of nodes in the system. And then I'm going to talk about the future. Where do we go from here? What do you do? What role can you play? What perspective should you have? And we'll close with that. So let's get started. Unless there's a lot of people there, so I won't stop for questions at each phase. But I know Ed will jump in if we need to. Okay. So I believe, where are we now? I think we're starting this incentives era. And why do I say incentives era and not blockchain era or cryptocurrency era or protocol consensus era, tokenization era? Because it's all about incentives, really. These components, these technical components, drive incentives, which are the secret sauce of these systems. And going a little deeper there, this incentives are an answer to where we are in terms of peak centralization. And if we look here, we've got a map, a timeline of 1990 to 2090. And I bring this up because people think that where we are is this place of permanence, that we're going to have the same top 5 or 10 companies in each category 10 or 20 years from now, that things can't change because we're here, we've made such progress. And you could start before or after 1990. I think 1990 is a great place to look at this look at it from this perspective, but we are at the beginning, and that's exciting to me. We're less than a third of the way there over a 100-year time span. And the other thing, this isn't a linear curve. We keep improving at a much, much more dramatic rate with each year because we're working on the shoulders of giants. And in this industry in particular is so interesting, where we have, on one hand, we've got people building core infrastructures to make the systems work. On the other hand, there's people building WYSIWYGs and just natural language processing to do smart contracts. You can code a smart contract and you don't even need to be an engineer. And I mean, that's mind blowing that that didn't happen in the first internet. This time's different. And I think it's a great time still, for a long period of time to get into space. You're still early, very, very early if you're getting in now. Okay, so when we think about these decentralized systems and we think about incentives, the UX in a lot of these initial cases won't be any different. Users shouldn't know that that the code they're using is open source and run on distributed servers. Users shouldn't if they're using a ride-sharing platform that's decentralized versus not, or a social network, or a search engine, or a healthcare infrastructure, or an identity system, or a microtransaction payment system, or a decentralized exchange. And it should feel the same to them, and I think that's really important to say. But the difference is around incentives. Why do they do this if it feels the same and they get the same result on the surface? It's because of the way these systems are built, we're able to give benefits, rights, governance, profit sharing, all of these things back to users because of the way these systems are built and managed and operated. And I'll get into that here in a second. But these are the key competitive weapons for you if you are looking at getting into the space as an entrepreneur or joining a startup in the space. And these are also weapons and elements you can use as a centralized business, as an existing business, even a big business. But you're going to see these tools come into play, and they're great opportunities to use incentives to build network effects around systems that when you're building them. Okay, so the other piece here is these things not only add new incentive structures, but new efficiencies and new business paradigms will be created. The way businesses are started and run are already changing. And I mean, look at the Ethereum Foundation and the success it's brought and to this whole marketplace. And this was started and run like no other organization before us, right? They didn't list on the New York Stock Exchange. They don't have this official group of individuals who essentially run everything. So this business model innovation is also playing a huge role here. And I think as that happens, you're going to see us fold into this next era. And things we're not even expecting will come about, where it's not just about the same UX and different incentives, but entirely different models. So stepping back, why am I talking about this? It's because we're talking, again, the focus here is the future of smart contracts. But is this incentives era brought to bear? How do we bring this to market? And there's some key pieces here on the back end, and in terms of one, consensus. That's how we make sure that everything's accurate. And these decentralized systems across this ledger can say, yes, these are the transactions, they're accurate. And that's how we have security. That's how we make these things work and make them trustless. And this is a way of essentially building a system of programmable money. And then also, that's a segue into having smart contracts, where smart contracts are a computation sitting on top of these systems and in these systems, where if X and Y happens, the money held in escrow then is transferred. And you're able to bring computation into these distributed systems, which opens up a lot of business opportunities. Okay, so open source software is such an important piece of this. Because the software is open source, we can all look at the software, because this software is running on all of these decentralized systems. And that's kind of the segue into distributed computing. If we can't look and see and trust and feel and help build and fix and improve these systems, then it's not a community-run system. And we also, as the community and network and people of users or those working the systems, also aren't able to trust the system if they can't see the code and know that it's doing what it says it does. And we'll touch later how that's very critical to the way smart contracts operate and what makes them important and then decentralized ledgers, right? We have blockchains. We ultimately are having these ledgers that live across this distributed computing environment run by this open source software that leverages consensus. where we can have programmable money and smart contracts. So all of these things, the implications of these things are what come to bear in this incentives era. And I will go a little deeper here. So thank you. Okay, what is a smart contract? And we'll start more simple. We're going to get more complex here. But smart contracts are programs that encode logic, conditions, and outcomes of agreements into these decentralized systems. They're executed by a network of computers, and ultimately they result in a state update to blockchains. There are many, many smart contract platforms and virtual machines. Blockchains are these distributed, trustworthy storage systems or ledgers, and the smart contracts are distributed, trustworthy computation. And these systems can be programmed and run so that we can create incredible efficiencies and systems of trust and business execution across a number of verticals. I'll get into that in a second. And Scale, by the way, this smart contracts really excite us because this is one of our unique capabilities to help make these things happen fast, not just transactions, but bringing state into this distributed computation. All right, so I'm bringing a lot to you guys quick, so I'll keep rolling. Let's talk about where smart contracts are valuable. This is a piece that we're an industry moving at 100 miles an hour, getting these use cases going across a lot of different areas. And I like to step back and think about where are these most valuable. And having been an entrepreneur in Silicon Valley for a very long time, I love drawing it back to the basics and then building it back up. So one, I think a good question to ask is, well, what are machines good at? What are machines or computers better at than people? One, speed and repetition. So machines don't get tired. Computers don't get tired. As long as they're plugged into energy and they're working, they can run and run and run and run at millions and millions and millions of times per second or more, right? And so machines are good at that. The other thing is they also have a constant real-time connection to data. So they, assuming the systems are set up in the right manner, are connected, whereas we are sleeping and not always having our fingers on the pulse to know when things are coming through and have been achieved, et cetera. The other thing machines are good at is pattern recognition. And I'll get in a second on how we can use the pattern recognition in smart contracts. Another piece here, judgment without bias. This is one of the most critical pieces. Machines or computers are biased only by their code, okay? They don't have other biases like we have as humans. They're biased entirely by the way they're designed and programmed. So that being said, what are the scenarios that are most impactful for smart contracts? One, high frequency transactions. All right, so where are these transactions happening a lot and at a super high rate? And the other piece here is when in these high frequency transactions, where are these contract terms repeatable and where they can be codified? If these contract terms every single time have to be changed by someone and they don't happen very often, let's say we're just selling 10 homes a year for $8 million and with a lot of different inputs, then you're not getting the value out of the automation component and able to let these smart contracts work to their full capability. Okay, so I mentioned pattern recognition. This is another very interesting area. This is something at Scale we're really excited about. We're building functionality to allow people to leverage AI and machine learning so you can predict pricing, fraud, et cetera, with pre-trained models. And so this is something that developers and entrepreneurs, engineers, we need to be thinking about this, to think about how we can use these models in smart contracts. And then if the infrastructure is there to help you execute on that, think about all the possibilities, okay? So there's a ton of potential. We'll get into the different areas and high-level areas and industries here in a second and talk more about that. But okay, low trust environments. Smart contracts are also very good when you have groups of people that don't want to have to trust each other. It doesn't mean they don't need to like each other, but for whatever various reasons, they're exchanging money and they want a system that is entirely biased by the code. And so low trust environments are optimal areas to implement smart contracts. Another piece here is getting benefits from immutability. If you want to keep the result of these contracts for a long time or forever. And also I have net included. sometimes you want to keep not just the individual transactions. You may want to, if Bob and Alice have 50,000 transactions every 6 weeks between each other, maybe you just keep the net of those every 6 weeks forever. And so there's ways you can do that when you use layer 2 as a service solutions, like we're providing at Scale, and you're able to define what things would be put back in a permanent fashion. Another great area to think about are middlemen heavy environments. So places where you've got inefficiencies, high fees, inequity, in terms of all the things we talked about earlier with the incentives. These are really, really sweet spot areas. So people that are, and companies and groups and organizations and entrepreneurs that are going to be able to think about all of these different scenarios are going to be able to find low-hanging fruit in places where, you're not pushing rocks uphill. You're kind of chasing them downhill, making sure they don't grow too fast, so they aren't, so they can grow in the right manner. So, all right, I'm going to move forward now to the next point. Okay, who will take advantage of this first? Which industries will take advantage of this first? So there's some really, really interesting use cases popping up right now in energy verticals where you're trying to incentivize end users to use renewable energy and push energy back to grids. Areas where in the internet and social where we can change benefits and profit sharing and governance and data ownership. Data ownership is a very hot spot here where smart contracts can play a role, and advertising exchanges and networks on the internet. Transportation, utilities, gaming, many, many, many opportunities across gaming. Insurance, healthcare, 2 other great areas. Life science, an area I've gotten to know a lot about over the years in terms of, so we're going to see IP development, ownership over your own genomic data, ownership in a group in decentralized manner of drug development, and supply chain opportunities within life science. So education, there's some amazing smart contract applications coming out in education to for identification and certification, and even open source education and approvals and certs for ed and payments around ed. And there'll be real dramatic changes in that space. Supply chain and IoT, this is a phenomenal area and an exciting area, in that this is one of these sweet spots where we have a lot of transactions and the inputs can be codified very easily. Imagine, RFID and these things that immediately can put into the system and go into the escrow to complete payment. So an area too where there's a lot of middlemen, and I think there's going to be a lot of optimization and leaning and efficiency and benefit sharing in that space thanks to smart contracts. Okay, financial and real estate, 2 other really, really great areas that are so broad in terms of the uses here. But this is a subsection of some real great areas I see. There are many, many more. And one of the fun things about this industry is, regardless of what world you work in and what tech there's opportunities to apply these advantages to different industries. And we're going to see people who have industry-specific knowledge and experience bring those their knowledge and their understanding of the way their systems work with these new systems. And we're going to see some really, really impressive projects started here in the next couple of years. Okay. Okay, well, why don't we use this today? How come, this already hasn't happened? Well, there's blockers. One blocker is, hey, the current blockchains are very slow and expensive. So we've got our cute little turtle here showing us the way and showing us how slow this is. But let's also just agree, though, this isn't a knock on these incredible systems. Look at how secure they are and look at how performant they are over time. And they're really playing their role, and they're doing a great job what they're doing. And I want to be really clear about that. And I am strong supporters of these systems. So Bitcoin is at 7 transactions per second, roughly. Ethereum 21, roughly. Lots of different specific numbers called out on those. Visa, though, 56K peak typically, and around 1,700 per second. So they're obviously able to do a lot more across the world at a time. And then I have this LinkedIn doing 4.5 million messages per second using their big data Apache Kafka infrastructure to do that. So you can just see how when you apply parallel infrastructure and big data infrastructure to messages and transactions, you can get a lot more scalability. Now, the question is well, can you do that in a decentralized manner? And I think, we think you can at scale. And I think there are a lot of people working on interesting projects to try to bring this type of performance to the entire world of decentralized systems. In closing on this point, smart contracts need faster processing in order to compete with centralized competitors and to realize new markets. And also, I say realize new markets, this isn't just about decentralization and centralization. We're going to see traditional standard companies really taking advantage of this and using it to their advantage too. And we're going to see new business models pop up, new markets pop up, and all as this infrastructure speeds up. Okay, so another interesting way to think about this is the trilemma. I'm using language here. I have to give credit to Kyle Samani at Multicoin, who wrote a really thorough blog post on this that I'd recommend everyone reading around the trilemma. So what it means is it's really hard to be scalable, safe, and decentralized all at the same time. It's not that hard to be two of the three, but being all three is difficult because they all have trade-offs. And so you'll see there are a lot of phenomenal projects out there today that are really trying to have their cake and eat it too, and that's what we're trying to go for, right? We want to be scalable, safe, and decentralized, and we want to build for that. Okay, so I'm going to go now into a little more detail and give you a very oversimplified version of this. In part, we've got people who are just coming into the space, and so I'll try to speak to both areas at both levels of complexity and depth, but this is intentionally oversimplified, just to be clear. Okay, so why are traditional blockchains slow? Traditional proof of work blockchains. So each node in the system has to look and validate every transaction in the system, and then they broadcast that to every other node in the system. And so when that happens, by nature, it's slow because everyone needs to validate everything. And then as the system grows, it gets slower because there's just one more validator or node or miner in the system that needs to approve, and come to consensus. So it slows by nature of just size and volume. So how do you get faster? That's what we're all trying to figure out right now, and work within that trilemma framework. So one way people are doing this is on the top left here, create a block with less validators. So maybe you have one and there's, you just have 21. You just have 21 nodes, and guess what? They're going to be pretty fast because there's only 21 of them. They're still going to work in a proof of stake model and move off of proof of work, but there's just less of them, or three. But what do you give up? You give up on decentralization, and so there's situations where that's not that big of a deal, and this will be very successful. But that's one method. Another method is we see out there with projects is some people want to keep this large selection of validators, but be able to randomly allocate and define who's going to be doing consensus. And this way you maintain decentralization while also refining who's doing the work so that you can keep that pool small and also get to a point of fast finality. So that's another thing that we're seeing happen in the marketplace and being tested that try to improve this. Another one is people are trying to create shards, so sharding, creating these sub-chains that are all working underneath the main chain. And so there's big, a lot of these big smart contract platforms now are working on major projects to change, and they plan to change over the next couple years and create sharding environments. And they're hoping for really, really great advantages when that comes about. Another area is combining a proof of work or proof of stake traditional blockchain with algorithmic consensus. So in this situation, you would have a traditional blockchain of tens of thousands or hundreds of thousands of nodes. And then what happens is they connect in a layer 2 as a service manner or a layer 2 manner into this other chain. This other chain then runs an algorithmic consensus. So let's say this other chain still has tens of thousands of nodes or validators. And then randomly, subgroups are put together in a similar fashion as we see up above. But when these groups actually do consensus, instead of each node broadcasting to every other node in the system, they broadcast a subset of the validation back to a subset of validators. And then algorithmically, in a leaderless model, they're able to build a block very, very fast. And so Stan, who is my colleague and the CTO of SKALE, and as I said, unfortunately he was sick, he was going to talk in great detail today about this. And this is where you could use a binary asynchronous consensus and get to and also apply parallel infrastructure, MapReduce infrastructure, and get a ton of scalability here. And so unfortunately, we're not going to go super deep here, but this is an area that we're really excited about. That's interesting. That's fully Byzantine fault tolerant. That empowers, in our view, this world, this new market here within a new market called Layer 2 as a service. And a little high-level overview of how this works from our perspective is, so a decentralized application are able to plug into, this is a traditional model, down through the virtual machine where the smart contracts interplaying here with the block and the transactions, and consensus is happening here either in a proof of work or POS or DPoS manner. But this is slow for the reasons we discussed. In this new Layer 2 as a service model, the dApps are able to, one, connect the Web3.js connector here to this other system, buy tokens and stake them into this other system to get access to this other system. And then what happens is the smart contracts are frozen and brought over to the new system, and we have this connector, and threshold signatures is one technique that can be used, BLS in particular. And you're able to, in a very cryptographic, secure, and accurate and speedy manner, bring smart contracts in full state over to run in this algorithmic consensus layer. And then when required, because this is acting as a Layer 2, and this could also act as just a Layer 1 back with a dApp, but again, we get back to the trilemma and really making sure you're having your cake and eating it too with security, speed, and decentralization. You're able to push things back to the main chain, and again, threshold signatures are used so that when in a fully Byzantine fault-tolerant manner, tokens are burned and that were cloned prior and put back into this main chain. So net transactions or anything desired can then process back through this main system. And then the first system speeds up, the second system does a lot of work, and it does it way faster and at a fraction of the cost. And ultimately, we're talking about this because we need to be able to help these smart contract applications or dApplications come to market, and they need ultimately lower costs and higher speed in order to do that. Last year, and I thank everybody for staying with me in this presentation where we talked about the market, we talked about our challenges, we talked about some techniques people are using to speed up things up, and we're all bringing it back here at the end to entrepreneurship and building and developing and programming, and all of us, I think, who are interested across our own verticals. I just want to say this starts slow, it's going to build slow, and it's going to feel like it happens overnight. And this version of the internet that we're all working on, I think, is going to happen tremendous. We've seen it happen from a token perspective and the market growth of people buying tokens, but I think we're going to see this from an actual usage perspective. Every day we're going to start using these applications, and it's going to seem slow, and then it's going to just happen overnight. So my advice to all of you is find a problem and solve it. There's so many tools at your disposal. Find that problem first, and find a problem you care about. Anytime you're getting in and starting a company, you got to be ready to do it for a really long time and work hard and push, because you have a lot of people that are, it's not just your own, it belongs to everybody, especially in a decentralized, permissionless, peer-to-peer network. So find a problem you care about and go for it. So that ends the presentation today. I tried to go through fairly quick because I know we're running behind with our presentations. So anybody that'd like to get in contact with us, please feel free to reach out to us on our Telegram or Twitter. And real pleasure being able to present to everyone today. I'm going to end the presentation and go back over to Ed here on the other screen.
Awesome. Thank you so much, Jack. That was a great presentation. I think looking at the audience chat, they really appreciated the bottoms-up explanation that you gave there. Apparently, that there are folks in the audience that really found the explanation of smart contracts very clarifying. We kind of skipped over that earlier on in Hack Summit, and not all the audience was caught up. And so I think you really helped many of our audience members to really get it. So thanks for that.
Hey,
we have time for maybe one quick question from the audience too,
Okay.
which is a noob question from Tim Miltz. He calls it a noob question. This is his description of his own question, which is, would a fair analogy for smart contracts be that while even non-primitive data types are technically classes, a smart contract would be a data type class that also has some methods, except there are classes that are instanced on machines that participate in a blockchain where said smart contract exists. To reword it, is a smart contract essentially persisting data, but also some code that can act on that data?
I think that was a really, really robust and well-written question. And I definitely, yes, essentially we need to think about it as we need to update state so we can run a computation. Ultimately, we have an escrow, right? Bob pays Alice, the money is held here. When the other event happens, then the money is transferred through. And so if it's codifying that and adding computation to the decentralized infrastructure in a trustless manner. I mean, it could happen off-chain, it could happen somewhere else, but like when we're talking about programmable money, and so we need to be able to program that money and make sure that it's approved and accurate, and these systems are secure, right? So I think phenomenal question, thank you. And I'm looking here at some of the comments. I appreciate all the nice comments here, and really a pleasure getting to know everybody, and awesome community, and again, a really great cause. So thanks for
great. And how can people learn more about your initiative? Where do they go to find out more about Scale?
Yeah, so what I'll say is we just are starting to come out of the woodwork in terms of we've been heads down writing code, over 50,000 lines of code, and we are getting ready to release a lot of information and really graduate to being a fully decentralized system here. So join our Telegram at Scale Official, and follow us on Twitter for now. Come to the SKALELabs.com website, and please input your information. And we're tracking and saving everyone's information, and we're going to be releasing a lot of information soon, and really looking forward to building a community, because we're building a system that's not ours. It's something that is open sourced and decentralized, and we need a community to do that.
That's great. And I'm sure you'll be hiring at some point as well.
We are, yeah, we will. So new jobs being posted soon. So I know there's a lot of great people here. We're looking to build the team.
Awesome. Thank you so much, Jack. We learned a lot from you. I appreciate you taking a stand for these nonprofits with us today and educating us on smart contracts and scalability. Very enlightening. Thanks again for your time today.
Thank you.
Guys, we'll be right back. We're going to have a completely different type of session coming up in just a second here. It is the co-founder and CTO of the Foam protocol, which is called Proof of Location, completely different than everything else we've seen here at Hack Summit, to find where you are in the world, almost like an alternative to GPS. So we'll be right back for that.